hockey right here. See this hit on Malky in here? Good Canadian kid Giroux lays the body.
And today on Newton's Corner, we've brought in acclaimed physics teacher, Mr. Paul Fox, to explain the physics behind our favorite hockey plays.
Yes, well, the body check is a clear demonstration of Newton's third law, which states that all action forces have a reaction force of equal magnitude and opposite direction. The action force of Giroux's body check creates a reaction force on Malkin, sending him backwards.
Wow, neat stuff, Paul. But my question is, how do we calculate the action force Giroux applies on Malkin?
Well, we can do this by applying Newton's second law, which states that force is equal to mass times acceleration. So, if Giroux is accelerating at 6 meters per second, and he has a mass of 82 kilograms, the force will be 492 newtons.
Alright, yeah, that's great, kids. Now, let's talk about face-offs. Tyler Bozak, a good Saskatchewan boy, really knows the face-off circle. Look here, he doesn't even have to work to win this draw.
Well, actually, Don, there is work being done here. Yes, when the puck is in the ref's hand, it is gravitational potential energy. As he drops it, there is work done on the puck. As the puck falls, its kinetic energy increases and the gravitational potential energy decreases. As it hits the ice does work on the puck to stop it, and the kinetic energy and gravitational energy are converted to thermal energy and sound energy.
Oh yeah, okay, physics can explain these things, but I bet you can't explain why Chara has the fastest slap shot. How much time?
2 minutes, Don.
Okay, good.
Back to your question, Don. So to explain the physics behind a slap shot, we have to look at both energy transfer and forces. As the player winds up for the shot, he has gravitational potential energy. As he brings the stick back towards the ice, the gravitational potential energy decreases, but he increases the kinetic energy of the stick. Next, he applies a force on the ice with the blade of the stick. The frictional force between the blade and the ice creates flex in his stick, increasing the potential energy in the stick. Finally, as the blade makes contact with the puck, the energy is transferred from stick to puck. The low coefficient of friction between the puck and the ice increases the velocity of the puck, in turn increasing the puck's kinetic energy.
Wow, interesting stuff! For our next segment, we will talk about a recent but integral addition to the game.
What's that, John?
Well, Don, that would be what we have come to know as flow, the iconic hockey boy hair. Here to help with our demonstration, we have hockey player and 2016 OHL draft hopeful, Patrick Harrison.
Good Canadian kid, that Patrick Harrison.
Yes, Don.
Ah yes, flow. Now, you may be saying, hold the phone. How can hair be physics? Well, the hair acts as an added layer of protection for hard headshots.
And don't forget, Paul, the reaction force of the ladies increases the longer and greasier the flow.